Okay, hey guys. I've heard from a couple of people that are struggling with this expanding bracket stuff, and a couple of people struggling with some factorising, and I imagine most people are going to struggle with this non-monic stuff because honestly it's a bit of an extension thing. So really just focus on these first two. So what I thought I'd do is quickly go through this sheet that I've uploaded. This can be your only work for this week. Honestly, just focus on getting these questions done. Maths base can be awesome because it really pushes you to get to that extension level. But if we're working from home, we need to be realistic, and sometimes maths bases can be a little bit tricky. Okay, so I'm going to go through a couple of questions, make sure you're on the right path. You can use this as a jumping off point and fill in the gaps, or maybe you want to have a look at one or two, try and do the rest on your own and come back and check your answers. Okay, so we'll start with the first one here, these expanding brackets. There's two main methods that you can use. The most common is the idea of FOIL, okay, which is a mnemonic device, which just means it's a way to remember what to do. So what you're going to start with is the F, which stands for multiplying the first part of each bracket. So that's going to give you x times x, or x squared. The O stands for outsides, so you're doing the outsides of the two brackets, and you'd get 3 times x, so 3x. I is for insides. Now notice here this is negative 5 times x, so you get negative 5x. And finally, L is for the lasts. You get negative 5 times 3, so negative 15. The last step is we need to group together what we can. It's always going to be these middle terms here. So it's x squared. Now I've got 3 of something, take away 5 of that same thing, minus 2 of it, minus 15. That's the most common method. My preferred method is what I showed in that video lesson. I like to draw up a little table like this. And you might think this is a little bit juvenile. I think it's quicker. And when we get to completing the square stuff later down the track and some more advanced algebra, this method is actually how we introduce it. So it's really useful. All you're going to do is go down one side, I'm going to write this x, and then I'm going to write negative 5 as its own thing. And then up the top, I'm going to write x and positive 3. Then this is a times tables chart. I'm just going to multiply, because we're always multiplying, to fill in each of these 4 gaps. So x times x is x squared, x times 3 is 3x, minus 5 times x is minus 5x, and minus 5 times 3 is minus 15. It's the exact same parts as before. And then when we write our answer, you'll notice it's going to be these diagonal bits here that have the same variable. So you got 3x's minus 5x's. So we can write that as minus 2x's minus 15. Same answer. You don't need to show you're working either way because you could do it in your head and that's totally fine. I prefer this method, especially if you're just starting out. Okay, so if you're not too sure, use this. FOIL is just an easy way to remember it. Okay, so we might jump to doing a tricky squared one. The trick with squareds, so this is a perfect square, meaning that it actually means 4x minus 3 times itself. That's what we call a perfect square. So now when you expand this, I'm going to use the method that I like, which is a quick little chart. I'm going to write 4x here, and I'm going to write negative 3. And now because it's a perfect square, that should be a times up here, by the way. It should be the same thing on the other side. Again, we're just going to multiply to fill in the 4 empty spots. So I'm going to do this in black maybe so it stands out. Now 4 times 4, because we do the numbers first, is 16. And then x times x is x squared. So if you're ever dealing with algebra and numbers, we times the numbers together and then we times the algebra together. So when we do 4x times negative 3 to fill that spot, you do the numbers first. So you've got negative 3 times 4, and then we've just got an x. Now you'll notice it's a different direction, but this is the same multiplication. That's always the case with perfect squares. Negative 12x, and finally negative 3 times negative 3 is going to be positive 9. So when I write my final answer, I'm just going to write 16x squared. Now I can't combine x squareds with just x's, which is why we don't combine those. but I can combine x with x. Now I've got negative 12 x's, take away 12 more, that's negative 24x plus that 9. And that's our answer. You can't do anything more with that. Okay, I might quickly rip through this last one down here, just because he has a little bit more algebra. I am going to jump straight to using my chart because he is a perfect square, okay, which means the squared is just on this, so it's the same bracket twice. I know that this is going to be 3x squared and this is going to be negative 4 for both sets of brackets. Now, if you want to do this with FOIL and you're not super confident yet, what I would recommend is just writing out both sets of brackets, and then we're doing the same method from that point anyway. So to fill in this first gap, I've got 3 times 3, because we do the numbers first, is going to be 9. And then I've got x squared times x squared. Now obviously there's going to be an x, and the trick when you're multiplying the same letter is you're going to be adding the powers on, okay? Because x squared really means x times x, and when you multiply that by another x squared, what you'll notice is that you have x to the power of 4, or 4x's multiplied together. So that's how we get x to the power of 4 here. Now for this gap, I'm going to do my numbers first. So negative 12x squared, this is the same thing. And then negative 4 times negative 4 is positive 16. Now when I write my answer, I can't combine x to the 4 with anything else, but I can combine my x squareds. You'll notice it is very similar to the question we did a moment ago. Now I went to write plus 24 because some people go, oh, you got a negative and a negative, that makes a positive. That's only when we're multiplying. So when you did negative 4 times negative 4, we got positive 16. If I've just got negative 12x squareds and I take away 12 more, I've just got negative 24 of whatever that thing is, right? X squared is just a thing, plus 16 at the end. Okay, so hopefully you can fill in the gaps on those expandings. It doesn't need to get harder than that. If you are trying to do questions harder than that in math space, maybe just leave it and move on, because you've definitely got everything you need if you can do these 6. Okay, so factorising. There are 2 examples there. I'm going to ignore those and jump straight to going through a few of these. Hopefully you can pick up where we're going. So the way we do this is we're trying to get it back into the form of x and x. So before we expanded the brackets. So obviously when we do that, x times x gets us this, which is our firsts. And whatever is the last or the second bit of each bracket is going to give us that last term. The trick is that we need to figure out what makes 5 that's going to multiply to 6. The easiest way to do that is to consider what are the factors. Now factors are numbers that multiply together to make 6. So you've got 6 times 1, or you could have 3 times 2. Now you could have 1 times 6 and 2 times 3, but we don't need to repeat those. And then what you need to consider is, can I use these numbers to make 5? Now notice it's positive 5, that's really important. So what I could do is I could go 6 minus 1, that equals 5. Okay, the problem here is that makes positive 5, which is all good, but then when I do 6 times negative 1, I'd be getting negative 6 as my number at the end. Okay, and I can't do that. Okay, even though it works to make 5, now it no longer works to make positive 6 there. So it can't be 6 and 1. So we try 3 and 2. I could do 3 plus 2, that gives me 5. And 3 times 2, notice they're both positive, also equals positive 6, which is what I need it to be. That means that they are my 2 factors, and then I can just jump straight to writing the answer, which is going to be x plus 3, x plus 2. And that is it factorised. I'm going to skip the next one and jump to here, and we'll do the same thing. So we look at 9 and we say, what are the factors of 9? So numbers that multiply to make 9. You could have 9 and 1, or you could have 3 times itself. Now 9 and 1, there's no way I'm going to be able to make 6, because I can either get to 10 or to 8. Hopefully that makes sense, because I could go 9 plus 1 is 10, or I could go minus 9 minus 1 is minus 10, but the number is still the same. Or I can go 9 minus 1 is 8, or I can go 1 minus 9 is minus 8. So there's still only 2 numbers. It's either 10 or 8, but I need it to be 6. So it's clearly not that set. So then what we can try is 3 and 3. I can add those 2 numbers together to make 6, and 3 times 3 also equals positive 9, which is what I need. That means I'm done. It's going to be positive 3 and positive 3. You'll notice this one's actually a perfect square because it's the same set of brackets twice. So we could also write that as x plus 3 squared, just like that. Okay, we might jump down here, try another one. I'm leaving some blanks for you, by the way, so that you can go back through this and try and fill in those blanks yourself. So, having a look here, we're going to go down. Now this one's quite tricky because we have a negative product here, a negative multiple, and a positive here. So that's a pretty damn good clue that one of our numbers is going to have to be negative for me to get a negative here. So, numbers that multiply to give 18. There's 18 and 1, but the reason I'm not even going to write that option down is because there's no way with 18 and 1 that I can make 7 just by adding and taking away. It's a silly answer to write. Instead, what I could do is maybe 6 and 3 and 9 and 2. Now, hopefully you're starting to see a pattern and get good at this and understand what you're doing, and you can jump straight to the answer, which is going to be 9 and 2. Right? I deliberately put 6 and 3 first because at first you may not be able to do that and you're going to write the full list out. If you are capable of jumping straight to the answer, which is going to be what, x plus 9, x minus 2, you can just write that answer straight away and you don't need to show any working. Okay, but for us who are still kind of figuring this out, we're using these numbers here to see if we can make the number 7. Now 6 and 3, there's no way I'm going to get 7. Because if I add them, I get 9. And if I find their difference, I get 3. So that's no good for me. But if I use 9 and 2, and remember I'm trying to get positive 7, I could do 9 minus 2, and that gets me 7. That works. And now what I need to check is, well, if I do 9 times minus 2, does that equal negative 18, which is what I need this time? And that also checks out. So that means my answer is, like we said before, positive 9, negative 2. Okay, the reason, in case you're wondering, as to why it's not negative 9 and positive 2, these numbers here do multiply to give negative 18, so that bit's all good. But when you were to expand all this, you're going to have negative 9 plus 2 as your x's. And that's going to give you negative 7x. But it needed to be positive, which is why only that one answer works. Okay, having a look at some bigger numbers here. Now the products of 40. I'm going to think the same way I did a second ago. I'm clearly not going to be able to use a big number like 20 or 40 to get 3. That's silly. So I need to think of smaller numbers that are going to multiply to 40. I could do 10 and 4, isn't too silly, and maybe like 8 and 5. Okay, and then I need to use those factors to see if I can make positive 3. 10 and 4 is only going to get me 14 or 6 by either adding or taking away. Whether it's positive or negative, I don't care. I'm just looking for the number. 8 and 5, I can either get 13 by combining them, or I can get 3 by doing their difference. And 3 is what I want. Okay. Now it's positive 3 that I want, so that means I want to do 8 take away 5. And that's going to give me my 3. And then you need to check, well, does 8 times negative 5 equal negative 40, which is what I'm looking for here, and it does as well. And that means that our answer is x plus 8, x minus 5. Okay, I'm going to keep going. Which one? We'll do this one here. Again, we look for factors of 15. The most common obvious answer would be 5 and 3. Again, 15 and 1 is not going to work because the difference is too big. I'm not going to get an answer of 2. Now, you'll notice here that I need to make negative 2. That means I'm going to have negative 5 plus 3, so the bigger number being negative, so that my answer is negative 2. Now that that's checked out, does negative 5 times positive 3 equal negative 15? That also works, and that means I've got my answer. Okay, and that's it. We'll do the last one as well. So here you're going to go, maybe, what could you do? You could do 8 times 3 is a reasonable answer. 12 and 2, probably not too reasonable because I'm trying to get a really small difference. And 6 and 4 is another really good one. 8 and 3, I can only get the numbers 11 by adding together, or 5 by finding their difference. Neither of those works for me. But if I try 6 and 4, can I make negative 2? I can do that, but the big number has to be negative, okay? And the small number has to be positive. So negative 6 plus 4, or feel free to write this as 4 minus 6. That's also fine. I just like to do it in terms of the big number first because that makes more sense to me. That's going to give you an answer in negative 2, which is what we want. And then you say, does negative 6 times positive 4 equal negative 24? Which is, again, what we want here. That also checks out. That means we're at our answer, which is negative 6 and positive 4. Okay, so hopefully that helps you enough with factorising that you can go back and fill in those blanks, or maybe attempt them all and then just check your answers, as well as expanding, which is a recap of hopefully where we're up to from last week. Okay, now the non-monics part. If you are clocked out, leave it. All right, stop there, focus on those 2 skills. Non-monics is something we can teach you in year 11 if you choose to do extension. Okay, but if you're sticking with me, we've got 2 methods here. There's the method we really should be doing, which we will have a go at, which is the slip and slide method. And then there's the quadratic formula. The quadratic formula is kind of just like a big old mallet that you can smack at any problem and it will work for you. What it gives you is the actual x value, so an x equals, which you'll notice isn't what we get by factorising. When we factorise, we get 2 brackets. There are going to be questions where this doesn't do the trick, okay? But with that said, this is something really tricky to learn, so only try this if you are fully awesome with expanding and factorising. So just quickly, I'll show you how to do one of each. We'll do the quadratic formula first, okay? And this is what we're going to be working on a bit at the end of this term, as well. So the trick here is that we're going to give a value of a, b, and c from our quadratic equation. A is the number in front of x squared, b is the number in front of x, and c is the number on its own at the end. C often stands for constant, and constant means a number that doesn't change based on x, so it doesn't have an x. Okay, that's what C is. So when you do the quadratic formula, all you're going to do is grab your calculator. And again, it's on your reference sheet that we're going to give you for any big test and exam you do. In fact, I have one handy. It's just here on the front page. Okay, so all you need to be able to do is spot A, B, C, and then you just type it straight into your calculator. I tend to put things in brackets because then you can't screw it up, even with powers, even with negatives, anything like that. So we're going to go negative b, which is 5. Now, I always just start with plus. You'll see on the reference sheet it has plus minus. Just start with plus. The square root of b squared minus 4 times a times c all over 2a. Now you type that into your calculator and you hit equals and you're going to get an answer. I'm not going to do that because I don't have a calculator on me right now, but it should be quite simple for you. Just type it all in. Maybe hit the fraction button first and then you can type the top line in and then move the down arrow to type in the second line. You hit equals and you get an answer, right? Whatever it is. Let's imagine it's like, I don't know, I don't want to give you a number because then it'll screw you up. Let's call it A, right? Now, you'll notice that in the formula it has plus and minus. All you have to do is go back to the equation, so just use the back arrow key until you get back up here, hit delete, and we're just going to put in a minus instead of the plus, and that's going to give you your second answer, because there's always going to be two answers. The same way that when we have our brackets, you'll notice there's always two answers. Okay, so that's kind of like the blunt hammer way to do it, where it's going to work for any question that looks like this, any quadratic. You can get the x values, which is kind of a step beyond even what we're doing here. Arguably, I think it's way easier and it's super practical. It's the thing you're going to be using if you do any engineering work. But with that said, we also need to be able to do some non-monic slip and slide. Now I'm going to try and remember this, and if not, this is going to be edited out. So the first thing you need to do is rewrite the equation without this a value, okay? But the trick is you're going to multiply that a value into the c value. So 2 times 2 is going to be 4. Now that you've done that, you should be able to factorize this expression. So you're thinking two numbers that are factors of 4. You've either got 2 and 2 or 4 and 1. The only way I can make positive 5 is by going 4 and positive 1. So that must be my factorization. Now the trick is I need to divide back in this a term by each of the constants. So I'm going to have x plus 1 on 2, x plus 4 on 2. These step numbers are just arbitrary, by the way. I don't know that it's really matching up with what I told you in the lesson. And now we do the slip and slide method. I'm going to do this all in one go. If this fraction simplifies nicely into a whole number, 1 on 2 doesn't because it's just 0.5, it's still a fraction. But 4 on 2 does because 4 divided by 2 is just 2. So if it simplifies nicely, we're just going to write that simple number. But if it doesn't simplify nicely, like 1 over 2, that's where we slide this 2 up and it sits with the x. So it's going to be 2x plus 1. And that is the factorization. If you can remember that, it's an awesome method to use. It is so much easier than what the textbooks are going to show you, and it can be really helpful. I might do one more for you using that slip and slide method, because if you can grasp it, wicked. So the first thing you do, we get rid of the a. I'll give this like an A, B, C if that helps you. A, B, C. So we're going to get rid of the a by timesing it to the c. So we're going to get x squared minus 3x plus 2. Now we can factorize it. You go, what numbers are going to multiply to 2? So factors of 2. It's literally only 1 and 2. They're your only options. And then you got to think, well, how can I use 1 and 2 to make negative 3, which is this part? So it must be negative 2 minus 1 is going to get you negative 3. So my factorization is negative 2 minus 1. Now the trick is I need to divide back through that original a term. Minus 2 on 2, minus 1 on 2. Now we do the slip and slide. If it simplifies nicely, so 2 over 2 is just 1, we're going to write it as that number. And if the fraction doesn't simplify, we're going to pop that denominator up in front of x. So x minus 1, we're going to slide that 2 up in front of x, and that is our factorisation. Okay, cool. So again, focus on expanding and factorising the basic ones. If you are able to do either the slip and slide method or you're comfortable using quadratic formula, you are aces ahead. Righto, awesome. Good job, guys.